Okay, so we started yesterday by looking at the ratios, the trig ratios from two basic triangles. A 30-60-90 triangle and a 45-45-90 triangle. And we discovered that the one thing that we do have to remember is we have to remember that sine 30 degrees is equal to a half. Because that allows us to start our 30-60-90 triangle. Now we aren't using calculators for any of this. This is purely memorization and applying to angles that are all similar. Okay, to triangles that have angles that are similar. So, yesterday we started and we talked about the coordinates. So the xy coordinate right here is found by taking, if I drew a line down here and made a triangle, this was 1, of course, this is your y, this is your x, this being the sine of 30 degrees, this being the cos of 30 degrees. Sine 45, cos 45, cos 60, sine 60. So again, all of those values will not change now. They will stay the same. The only thing that changes is the signs on them. So for instance, if we continue on with this today, and we go up to here, there's 120 degrees right there. Now, if I am referring to my reference angle, if I've got 120 degrees, that means that that angle comes from the x-axis over to there. What is the reference angle for this triangle? 60 degrees, right? So then I'm going to use the same two coordinates as I would for 60 degrees. So therefore, the cos of 120 would be a half, and the sine would be root 3 over 2. But which value is negative in this quadrant? Your x or your y? The x. So this becomes negative 1/2 and root 3 over 2. So the only thing that changes, these values stay the same as the reference values in the first quadrant. The only thing that changes is the sign on it. Okay, so let's look at this guy right here. So that's 150 degrees. 150 degrees. So what do you think the coordinates are at 150 degrees? What's the cos of 150? The cos of 150. Awesome. Good job. Negative root 3 over 2 and 1/2. Very good. Okay. You have this on paper somewhere, Carolina? Mm-hmm. Did you start that yesterday? You want to keep going with it. Okay? All right. 180 degrees yesterday because our radius is 1. Makes that coordinate negative 1 and 0. So let's go down here now. What is that angle? 210. So I have 210 degrees. And what are the coordinates at 210 degrees? What's the reference angle? What's the reference angle? You're going from 180 to 210, Rory. What's the reference angle? 30. So look in the first quadrant at 30 degrees. What are the coordinates? And 1/2. So they stay the same. So all we're going to do now is add negatives to them. Okay? So again, it's all based on your reference angles in the first quadrant. So now, I draw this down. That's now 240 degrees. What's the reference angle now? Reference angle is 60. Therefore, what are the coordinates? Excellent work. Negative 1/2, negative root 3 over 2. Are we following this so far? Yeah? Anybody have a question about it? Yes, Mary.
Like, where does the root stuff come from?
When I do the sine of 30 degrees, I know it's, if you punch it in your calculator, it gives you 0.5.
Yeah.
Which means the ratio of the opposite over the hypotenuse is 1/2. 1/2. Now I need to find what this side is. Okay? So if I didn't know this side, I wrote it on there, but if I didn't know this side, I do this. Use Pythagoras' theorem. Square root of that squared, subtract the square root of that. Sorry. The square root of this squared, subtract that squared. So 2 squared is 4. 4 subtract 1 is 3. That becomes root 3. So now that I know all three sides, the sine of 30 degrees is 1/2. The cos of 30 degrees is root 3/2. And the tan of 30 degrees is 1/√3. Sine of 60, root 3/2. Cos of 60, 1/2. Tan of 60, root 3/1. That's where the square roots come from. And you have to remember this guy in order to bail yourself out if you don't know anything else. You need to know that the sine of 30 is 1/2. Okay? All right. Any other questions so far? All right, so now, down here, that guy is 300 degrees. And this guy over here is 330 degrees. I want you to fill in the coordinates. Again, it's all about the reference angle. And the reference angle is made with the x-axis. Your reference angles in the first quadrant are 30 and 60. So that makes this the same and this the same as this. Okay? So 300 degrees for the coordinates. 1/2 and negative root 3/2. Excellent. What are the coordinates for 330 degrees? Brittany's got it. Okay. Who's not following this? You better be honest. The reference angle. Okay, so we wrote this down yesterday, right? So take 360, subtract the angle. So 360 subtract 300. 60, that's your reference angle. 360 subtract 30, that's your reference angle. 210 subtract 180. 240 subtract 180. Those are your reference angles. So you use that information to find your reference angle. Okay? All right? Okay, so far, any other questions? Who else is not getting this? Yes, Brendan.
Can't you just, like, if you look at the 300, isn't it exactly the opposite of, like, 120, except it's like the same as 120, but just, it's not just switched, and the same
That's exactly right.
for the other two opposite columns.
You're 100% correct.
So, okay, you can just do that with it.
Yeah. Yeah, you can. So what Brendan's saying is if you draw this line and you continue it all the way up, it's going to give me the same coordinate as this guy. You draw this line all the way through here, it's going to be the same coordinate. The only difference is the signs. Okay? Now, let's finish this off. What's the halfway point between 180 and 90? 135 degrees. What's the reference angle? $45 degrees. 180 subtract 135. So it's the same coordinates as, same values, different signs as 45 degrees is. So what is it? Negative root 2 over 2 and root 2 over 2. Right? $225. 225 degrees. Doesn't change, does it? So what's the difference?
They're both negatives.
They're both negatives. Exactly right. And then over here, 315 degrees. What is it here? Good job. Right. Okay. Now Mary, just look back one page. This guy is 1 and 1. And that makes that, if I use Pythagoras' theorem, root 2. Because 1 squared is 1, 1 squared, right? So now it becomes 1 over root 2. But I rationalize it. So I times it by root 2 over root 2. And that gives me root 2 over 2. That's why it's written like that.
So why do you have to rationalize
It
it?
just, you don't really want a square root on the bottom, if at all possible. Although I leave it down here for tan. But
We're never gonna use.
yeah, we won't use tan this year, but we need them for next year. Okay? Alright, so far, there you have it. There's what I refer to as the unit circle. Again, it's called the unit circle because your radius is 1. And all of these coordinates around can be found by cos theta, sine theta of the angle. So what's the point of this? This means that if I ask you what the cos of 240 degrees is, you don't whip out your calculator and tell me. You say, okay, well the cos of 240 degrees, that's a reference angle of 60. That means it must be a root 3 over 2. Sorry, it must be on 1/2. Therefore, it's negative 1/2. Now, one thing I did the other day that you didn't, I said, well, you don't need this just yet. Here's where I'm going to do it. In the first quadrant, and maybe, you know what, I wrote it wrong actually. Now that I think about it, I completely wrote this wrong. So you do have to change this one thing. One thing, not off the circle, but I wrote one thing wrong. I spelled the word in the wrong spot. Okay? Which value in this quadrant is positive? The x. And which one represents the x? Cos. C.
Oh, this is the casting?
Yeah. Which one's positive up here?
Both.
All of them. A. Which one's positive over there? Sine. And down here? Tan. Because remember, tan is y over x. Sine over cos. So when I divide this by this, or this by this, it's a negative divided by a negative, which makes tan always positive here. I believe I started in the first quadrant and wrote it the other day. So just change that.
Yeah, you did.
Yeah, I did. Okay, I didn't catch it until now. All right? How we doing? So all of 2.1 and 2.2 deal with just this circle here. Okay? The biggest thing is, when we get into grade 12, we hit this really hard. So the only thing that we add to this is what we call radians, which we will look at some point this year. We look at radians, which is another way of measuring angles. But radian measures the distance, the circumference of the portion circumference of the circle. That's all that we add to this in grade 12. We do this is important to kind of hit at now, work on it a little bit here, and then in grade 12, we hit this hard. We do 2 full units on this alone. okay? And we start to learn, okay, if I say to you, for instance, I said, I want the measure of 105 degrees. I want the exact value of it. Well, it's not on that circle, but if I add an angle of 60 and 45, it makes 105, and then I have what we call an identity, and we plug it into the identity, and I can solve for it. So that's what you're doing. This is where this all leads to, okay? So right now, it's just introductory to you. Can you use this to find the answers in the book? That's basically all it is, okay? But there is one aspect of this that we're going to do on Tuesday that we talked about in applied math. When we did the law of sines in applied math, remember how many angles could I get when I used the inverse sine? I could always get 2, right?
Yeah, same value.
Same value?
If it equaled 180.
30 and 150. What do you notice? What's the value of the sine of 150? 1/2. What's the sine of 30? 1/2. What's the sine of 60? What's the sine of 120? They're all the same. So we are going to do that next week, but we've already done this in applied. When we do ambiguous triangles, which we have to do again in this class, okay, it's already done. So the beauty part of this for you guys is if you look ahead to 2.3 and 2.4, we've already done sine law and cos law. That's
So-
next.
That's just the whole chapter, just repeating the cos and sine laws.
Pretty much it. So for those of you that have taken it,
So
gonna
we
be a
would
lot
have been
easier.
like, so watching that like cos at the end of the line equals like
Yeah, like you have to work with
squared
those
minus
equations
bx
again.
or whatever,
Yeah.
for a minus
Yes.
b.
yeah, so you do those again. Okay? This is enough information for you to do 2.1 and all of 2.2, I believe. Let me see your book, please, Rory. Okay? I don't think I need to go over, oh, I should look at the example questions for 2.2. That's what I do right now. Okay, yeah, and in fact, so this is what we refer to as the unit circle. Now, what happens, it says, the point P, 12 and -9, lies on the terminal arm of an angle theta in standard position. Determine the exact trigonometric ratios for sine theta, cos theta, and tan theta. So now, when we did this in grade 10, and when we did this in grade 11, applied, I would give you the sides of a triangle, and you would have to find the missing parts, right? We're going to do the same thing now. The only difference being is they're going to tell you a grid coordinate, and then you find it that way. Okay? So, if you're looking on 2.2, what's the first page of 2.2? Thank you. Trusty. 12 and -9. So this on page 69. So we're going to draw this out. So the first thing I do, here's my grid, and I'm going to go right here, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, down to here. So there's the coordinate 12 and -9. And it wants me to write out the trig ratios. Sine theta, cos theta, and tan theta. Okay? So I'm asking you to write out the trig ratios. Now, when we've done this in the past, anytime we worked with right angle trig, I would ask you for a specific angle, and you'd have to find it. So what you would do is you would take the trig ratio, and then you would go second function sine of that, right? But now I don't need to do that. All I need you to do is tell me what the ratio is. So I'm going to create a triangle here. Again, my angle is always made with the x-axis. So what's the distance from here to here? 12. And what's the distance down? -9? Agreed? Okay. So in order to get the sine ratio, where does the sine ratio come from? Opposite over hypotenuse. So what am I needing in order to do this question? Say again? I need the length of the hypotenuse. Okay? So 12 squared is 144. 81 squared,
You mean just.
or sorry, 9 squared is 81. So I got 144 plus 81,
225.
225. So then what's the square root of it?
15.
15. Okay. So what's the sine of the angle? What's sine theta? What's the ratio? What's the side opposite my angle? -9. What's the hypotenuse? There's my ratio. -9 over 15. That's it. What's the cos of the angle? 12 over 15. And what's the tangent of the angle? I'm done. That's all it's asked today. In that part of that. Okay? So how is this any different than what you did in grade 11 or grade 10? It's not. You draw the grid and then, excuse me, then create the triangle from your coordinate. And then write out your ratios. They're not even asking you what the angle is, they don't care. What they want you to do is, can you solve the ratio of this? Alright? Determine the exact values of the sine, cos, and tan ratios for 120 degrees. Alright, so I want the sine of 120 degrees. I want the cos of 120 degrees. And I want the tangent of 120 degrees. Alright. What's the reference angle? 60. So what's the coordinate of 60 degrees? 1/2 and root 3 over 2. Right? What's negative in that quadrant?
Sine.
The x is. That's right. I'm talking 120. What quadrant is 120 in?
2. So
Quadrant 2. So then,
sine.
sine's y, Rory.
Never mind. Oh, that's positive. Yeah, never mind.
You okay?
Yep.
Okay. So then what is the sine of 120? What's the y value of the coordinate?
Oh, root 3 over 2.
There. What's the cos value of 120?
-1.
What's the tangent in this case?
No, 1.
Okay, so, no, it's not 1. How do I find it? Opposite over adjacent? Yes. But I'm in a situation here where I don't have the triangle drawn. All I have is the coordinate listed. So how do I find it? How do you find tan? No. Go ahead. Yeah, you're on the right track, Britt. Okay? If I'm only given the coordinate, tangent is y over x. So let's take sine over cos. So what's my sine value? Root 3 over 2. Over my cos value, which is -1/2. So I have root 3 over 2 times -2 over 1. What am I left with? -√3. So if I don't have my triangle drawn, and I don't have my unit circle in front of me, and I don't have my chart that I wrote out yesterday in front of me, I have to take the y value of the coordinate over the x value of the coordinate to get it. Okay? this question. So, any questions about this too? Example 2. Now, right now, as you go through these questions, not for the test, but for right now in class, I will give you a full unit circle that's done nice and neat, and you wouldn't have to do this. You could look it up. You can look it up on your unit circle. But what's going to be required of you for your test is you need to be able to draw that first quadrant. You need to be able to draw the first quadrant. I'm not asking you to memorize all of it because if you can draw the first quadrant, everything comes from that first quadrant, so you don't have to know them all by heart. You just need to know 30, 45, and 60. And then the rest all match up. Okay? Now, this question is asked on the provincial exam in grade 12. This next question, example 3. Always ask this question. So, there's 2 ways in which we can do this question. I'm going to show you both. I like one way over the other, so you probably will as well. Suppose theta is an angle, and actually I'm going to show you my only method, the one method. I don't want to use the method they use. An angle in standard position with terminal arm is in quadrant 4. Okay, so I'm going to draw myself a grid with this being down here. Because I know it's in quadrant 4, right? And it says that the cos ratio, so again, I'm going to draw myself a triangle, and theta. The cos ratio is root 33 over 7. So if I'm labeling my triangle, that's square root 33, right, over 7. Adjacent over hypotenuse. Fair enough? Okay? This is the easiest way to do this question. When we do it in grade 12, this is the way I show you how to do it. Alright, now, it says that it wants determine the exact values of the other 2 trig ratios. I want to know what is sine theta and what is tan theta. Again, I am not working with angles right now. I just want ratios of one side to the other. So what's the first thing that you think I need to do here in order to solve this question? Find the last side. That's exactly right. How am I going to find the last side?
7 squared subtract root 33 squared.
Awesome. 7 squared subtract root 33 squared. What is 7 squared? 49. 49 subtract 33 is what? Stumper. 16. What's the square root of 16? Can we do that quickly? Okay, so that's 4. Alright? Now, when you take the square root of something, what do we got to remember? What is the square root of 4? 2. Okay? Can it be negative 2? Yeah? For me? Okay. What is 2 squared?
4.
What's negative 2 squared?
4.
Still 4, right? So when I took the square root there, I have to understand that because this is in the 4th quadrant, what value is actually negative on this right here? That guy is. So now, tell me, what is the sine of theta? What is it? Negative 4 over 7. And what is the tan of theta? Well done. So I'm just talking trig ratios. I'm done. So I said, it's an easy question. This is an exam question in grade 12. They'll ask you one. They have a little bit more added to it. They actually put 2 things out, and then you have to bring it all together. But this is the very basis of it. This is where we start this. Okay? Any questions so far? Yay, nay, are we okay? Alright? If we don't speak up, I gotta keep going. Alright, the last thing you need to do today. Again, we go fast, there's lots in this. I don't find it difficult because we've done some of this already in terms of the applied. So for those that didn't do it, it's new. So if I'm going quick, you're gonna have to do, say, whoa. All right, now, look at page 71. This is an interesting one. Okay, it says 4 tan theta equals. The ratio is what? Minus 9004. So that's the ratio of my two sides. My side opposite over my adjacent, when I divide them, gives me minus 0.9004. All right, I want everybody to pay close attention because I'm going to teach you the way that you're going to solve this. Again, in grade 12, you have to do this. So, the first thing I'm going to do, understand one thing. There are two angles between 0 and 360 degrees that are going to give me that ratio. There's two angles between 0 and 360 that are going to give me that ratio. So what I want to do is I want to find out what both of those are. So the first thing I do is find out what the actual angle value is. So I'm going to do this question and I'm going to find the reference angle in the first quadrant. So I want you on your calculator, now's the time to use your calculator.
I forgot.
Put in second function tan 0.9004, please. What's that?
Or 42, I guess.
41.99998.
So is it 42 then?
Yes, 42.
Okay. So I'm going to go with 42.000. All right? I got to get used to 3 decimal places because I'm going to do that throughout grade 12. I got to get used to it. So there's the reference angle in the first quadrant. So the second question you ask yourself now, it says tan theta is negative 0.9004. What are the two quadrants the tan ratio is negative in? Say it again. What are the two quadrants that tan's negative? That's why I write cast out.
2 and 4.
2 and 4, that's right. That's why I write cast out. All right? Cos is positive here. They're all positive here. Only sine is positive here, and only tan is positive there. Right? That means that in these 3 quadrants, the other 2 ratios are negative. This one, they're all positive, but these 2. So that means that tan is negative in this quadrant, and tan is negative in this quadrant. Would you agree with me? Yeah? So what I want to do then, is I want to find out what this angle is here. I want to find out what that angle is, because that's going to be, when I take the tan of that angle, I'm going to get that as my ratio. So what is that angle? What is it? How come 138, Brittany? You're right. Pardon me?
42 would be
The reference angle? Yes. Brittany's right. This is the reference angle right here. That's the reference angle, right? So if that's the reference angle, then what is that angle? 138 degrees. Punch into your calculator right now, tan 138. Do you get negative 0.9004? Yeah, you do. All right, let's find the one down here now. So I want this now. So how do I find it? Go louder. 360 subtract 42, which is 318 degrees. That's right. 318. So if you punch tan 318 into your calculator, you're going to get negative 0.9004. So here's how I write my answer. I put my reference angle down first. And then I put the 2 quadrants that tan is negative in because that's what the ratio had to be, was a negative. And I write it out, 138 degrees and 318 degrees. That's it. That's the whole question right there. So the difference between what you have done since grade 10 in trigonometry, when this presented to you, is you would have done second function tan and got an angle. Now, it would have given you the negative 42 degrees because you would have put a negative in there, which would have given you this angle down here, which we don't want. But the difference being is now I have to find two angles each time. There's two angles between 0 and 360 that will give you the same trig ratio. You follow? Okay? Alright, we've covered a lot of material today. A lot of material. So we're going to take the rest of today, which is about a half an hour only. We'll take most of Monday to tidy this up. And those that keep going, or Tuesday, sorry, those that keep going can go into sign law next. You already know how to do it, with the exception of a couple of you. So I'm more focused on the new stuff, 2-1 and 2-2. This is imperative that we nail it out because in grade 12 we use this a lot. Okay? So our focus will be on this for the next, half a day today and all of Monday or Tuesday again. Okay?
I mean, just get the cosine there. And it's you have all the sides, do you use -2 or -2?
Any other questions about today's work? I know it's a lot. Okay? So this guy right here, this guy right here, those are grade 12 questions. So those are questions that we have to focus on when we're doing this, and we gotta make sure that we hammer and we know how to do it. So that next year when you take the grade 12 class, you'll be good to go. Okay? Alright, you have the rest of today and Tuesday to finish that up. Alright?